In this video, we will explore how to resolve the Packet Tracer Lab 2.2.4.9 configuring port security. But before we even go ahead, you're probably wondering, what is port security?
A growing challenge facing network administrators is determining how to control who can access the organization's internal network and who can't. One example, someone comes into a business, then they plug in their laptop to that business network without the network administrator's knowledge. You might think this is an unlikely scenario, but it does happen. At your organization, a salesperson can come in to demo products, and it will just pull the Ethernet jack on a PC and connect it to their laptop, hoping to get internet access. How can you stop that? Well, Cisco's port security feature remembers the Ethernet MAC address connected to the switch port. It allows only that MAC address to communicate to that port. If any other MAC address tries to communicate through the port, port security will disable the port.
In this activity, we will configure and verify port security on the switch. As we said earlier, port security allows you to restrict a port's ingress traffic by limiting the MAC addresses that are allowed to send traffic into the port. Now, to do this, we want to actually access the command line interface of switch 1. And at the prompt, we want to type in enable command to transfer us into previous exec mode, and then the configure terminal command to transfer us into global configuration mode. Now we can either type configure terminal in full, or we can abbreviate it as I had done at the prompt. Either which way will work. Now we also want to specify the interface range to basically cover the two fast Ethernet ports. Now to do that, we'll type in interface range FA 0/1-2 and press enter. Now next, we want to configure port security. To do this, we'll type in switch port security, and press enter. Okay, now we want to next we want to set the maximum so that only one device can access the two Ethernet ports. Now to do that, we'll still do switch ports security, but we'll add in something different. We'll add in the word maximum, and then we'll add in the number 1 in this case, and press enter. Now we want to secure the port so that the MAC address of the device is dynamically learned and added to the running configuration. So we'll still do switch port security, but we'll add in this extra one, this extra option. We'll add in MAC address sticky and press enter. Next, we want to set the violation so the two fast Ethernet ports are not disabled when a violation occurs, but packets are dropped from an unknown source. Now, as I said earlier, say a rogue computer was to connect to the same Ethernet port as one of these computers on the network. Now, port security, by definition, will basically block that computer from being able basically be able to communicate with the other computers on the network, because it doesn't have the proper MAC address. So to do this, we'll still do switch port security, but we're going to add in something extra. We're going to add in violation restrict. Now, before I go ahead and press enter on this, I'm going to type in a question mark and then give you the various, basically the various violation modes. Here are the specific port security violation modes. Now, the protect violation mode is designed to drop packets with unknown source addresses until you remove a sufficient number of secure MAC addresses to drop below the maximum value. The restrict mode, which we will be using, drops packets with an unknown source addresses until you remove a sufficient number of secure MAC addresses to drop below the maximum value and causes the security violation counter to increase. Basically, go like 1, 2, 3, 4, etc., etc. Last but not least is the shutdown violation mode that puts the interface into the error disable state immediately and sends an SNMP trap notification. But in this case, we want to do restrict mode, and so we'll do that. Press enter. Okay, now we're set. Now, let me see. Now, all we got to do now is we'll sort of exit to go basically back up one level, back up to go back up to global configuration mode. And then what we want to do is we want to disable all the remaining unused ports. Now, as a hint, Cisco says to use the range keyword to apply the configuration to all the ports simultaneously. So to do this, we need to type in interface range FA 0/3 through 24, a comma, and we also need to get all the gigabit ports, so it'd be GO/1 through 2, and press enter. Okay, now we're set. Now all we got to do is type in the command shutdown. Okay, so far so good. Okay, now we just type it in to go back up to user exec mode. Now we want to just make sure that port security is in fact enabled. We'll do like a show port dash security interface. Okay, and then we're going to do fast Ethernet 01. Okay, now showing that port security is enabled. The port status, the security up, it is in restrict violation mode, and the maximum MAC addresses in this case is 1 for this particular port. So what we are going to do now is we still got to prove that port security is indeed running. So we need to verify. So we're right into part 2 of the packet tracer lab. So what we're going to do is from PC1 we want to ping PC2. To do that, we're going to bring up the PC's command prompt. Then we'll type in, say, ping 10.10.10.11. Press enter. Okay, that looks like that's going okay. We're able to ping PC2 from PC1. But we also need to verify that port security is enabled and the MAC addresses of PC1 and PC2 were added to the running configuration. Now to do that, we need to go back to switch 1. And first we're gonna show the fast Ethernet port 1. Now we're gonna see some different, basically some different information. Now, total MAC addresses went from 0 to 1. Sticky MAC addresses went from 0 to 1. And it's also showing the MAC address of PC1. And to verify that, we'll just go and we'll do an IP config /all. Okay, now got we got the physical address right here, and also the last source address BLAN, that's also showing the physical address. Those two physical address match, and so we know that it's set up. Now, but we also need to check PC2. So I'm going to close PC1, go to PC2, also go to the command prompt. Okay, I'm going to ping PC1 from PC2 at 10.10.10.10. Okay, that's doing okay. Okay, so we'll then switch from fast Ethernet 01 to fast Ethernet 02. Okay, that's looking good. And that changed also. So we know that port security is enabled. The port status is secure up. It's in violation restrict mode. And maximum MAC addresses is 1. Total MAC address is 1. Configure MAC addresses. Okay, that's a little bit troubling. Sticky MAC addresses is 1, and the last source at MAC address, it does give a MAC address, but I'm going to do like an IP config /all. Okay, and it shows, and the physical addresses match right from here to here. So looks like we're sort of good, but okay, the real test is this. We're going to attach a Rode laptop, basically a Rode laptop, to any unused switch port and basically test it out to see if that Rode laptop can even try to connect and communicate with the other PCs on the network. So, but so to do this, I need to switch this cable from PC2 over to PC1. So I'm going to connect it to the fast Ethernet port. I'm going to give it a little time, like maybe like 10 seconds or so. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Now, right now, it shows on the packet tracer log like this little light. Usually, if it still stays red, nothing's gonna happen. But for our application, what we're gonna do is we're gonna go to the Rogue laptop, go to the command prompt. Okay, we're basically trying to make like PC2, so we're gonna try this, try to connect to PC1. And to do that, we'll do a little ping command, and we'll do like 10.10.10.10. Press enter. Not looking good. Request timeout. Oh man. Request timeout. Man, come on. Like, give a little hacker love. What's going on with the request timeout? I'm a hacker. You're supposed to be let me in the network. Bastards. It is. This is terrible for me being a hacker. But anyway, it's good. But it's good being a network administrator. So okay, close out of that. Let's see. What we'll do is we'll switch this back to PC2. Now you probably already know, like technically we already finished the lab. Like we're seeing here, the completion level is at 100%. That kind of like a nice way of saying that we completed all the packet tracer steps that we needed to do. Technically, I should be sending this to my instructor at the college saying, "Yeah, I did it. Cool." But we're not done. We got to verify just to see that PC2 can connect into the network. Now, while I was speaking, you saw that light right here. It was red. Now it's green again. So it looks like it's going to be okay. But again, for our edification, I'm just going to sort of back it up to ping PC. Yeah, basically ping PC1. So done it and it's gone. It's doing it. No packet loss. And so we're all set. We're done. Um, I hope you enjoyed this video. If you do, please like, subscribe, and by all means, please share. And those commercials, go ahead and watch them. Please watch those commercials because you watch those commercials, they're good for me. And me being a starving college student, I need all the money I can get. But other than that, and anyway, I hope you have a good day and see you again soon.